Welcome back. Now that we have a fairly detailed understanding of what patterns of insights are, what bus metrics are, and how we can use them to tailor our analysis for a particular data set, we are going to try and apply it on this particular data set. That is the Titanic data set. Essentially, this is a data set which contains details of about 800 passengers that were unfortunately aboard the Titanic in 1912 when it sank. And the idea is how well can you predict who's going to survive and who won't survive. So we already have this data set downloaded. You can just search for this data set on Kaggle. You can just Google Titanic dataset, and the first link, probably the first link you're going to find is the link to the Kaggle dataset. You'll just have to go ahead and download the data, which we have done, and we have it here. So this basically is the main file in that dataset. Let's go ahead and open it. So there we are. Let's maximize this a little bit. Let's zoom in, and also let's freeze the top row as is the custom, and there we are. Now we are ready for some analysis. Now, one of the first things we are going to do is, instead of diving headfirst into the analysis, we are going to draw on the patterns of insights that we have learned in an earlier video and try and see if we can come up with certain questions based on those patterns, and then we are going to use those questions to drive our analysis. Essentially, we are going to go through each pattern of analysis and see what sort of questions we can draw from it. And instead of doing the analysis willy-nilly or just going through multivariate, bivariate, or univariate analysis, we are going to use these questions and try to find their answers through whatever analytical tool that we can come up with. So let's try and come up with a list of questions. So let's try to write down our questions here. Let's just simply rename this particular sheet to patterns of insights, and there we are. Well, this too needs to be zoomed to 200%, let's say. And well, the first thing we are going to need is a list of columns, because until we know what each column means, we wouldn't really be able to come up with questions. So let us copy over the columns from the first row of the sheet. Now I can straight away see that passenger ID is just an ID of the passenger, so we're probably not going to need this column because we can do nothing with the ID itself. So let's copy the remaining columns and paste them over here. Actually, we shouldn't be having them like this. Let's try and lay them out in rows. So we can do something like transpose of this particular selection and then close it, and there we are. So we can try and see if we can delete this. Well, you see, we can't delete this because then the transpose will mess up. So let's leave it like that. Let's just delete this particular row. There we are. So we have the name of the column, and let's also add what that per column means. So if we look at the column survived, we see that it's basically a column which has values in 0 and 1. And if you go back to the page from where you downloaded this data, you'll see that these are basically binary indicators of whether a particular passenger survived or not. So essentially, a 1 means that a particular passenger survived. This particular person, Mrs. Jack Heath Futrell, she survived, but Mr. William Henry Allen did not survive. So let's try and add that information here. These comments are later going to help us when we try to frame up our questions. P class is essentially, again, an integer indicator of the class of the passenger. So essentially third class, first class, and second class. So here we can simply say passenger class. Name is self-explanatory, sex is self-explanatory, age is self-explanatory as well, We don't know what SIB-SP is. So let's go back to the to the page where we got the data from and look at the data dictionary. And here what they have said is that SIB-SP is the number of siblings or spouses aboard the Titanic. So essentially for each passenger, how many siblings or spouses overall were aboard the Titanic. So let's just call it, let's just simplify it, say number of siblings and spouses. Well, you would assume everybody to have only one spouse, but you never know. Then again, the next one is Parch, which is the number of parents or children aboard the Titanic. So we have siblings classified separately and parents and children classified separately. Ticket. So ticket I think is just the ticket number, and that I guess is just going to be another unique ID. So not going to help us really. Then passenger fare is self-explanatory. Cabin is something interesting. It's like cabin number. It's possible that multiple passengers shared a cabin, so multiple people could have a cabin number. And let's say, and we have also something called embarked. So let's see what that means. Here, the data says that embarked is basically the port of embarkation. If you go back to the original data set, which is in this particular sheet, we see that embark contains S, C, and Q, three different unique values that keep on repeating. And the website tells us that C is Cherbourg, Q is Queenstown, and S is Southampton. So let's just copy this and paste that into our data dictionary. So now the next thing we are going to do is try and look at some patterns of insights, and based on that try and see if we can come up with some questions. So let's try and do that. So the very first pattern of insight that we know is, as we know, called an unknown result. So these are the most common types of patterns that are the most common types of insights that we are going to draw. Let's simply list down a bunch of things that we might want to generally find out through this data set. So these would all be unknown results so far because we know nothing about the data so far. Obviously, since it's a data set about the passengers of the Titanic, we might want to find out what is the survival rate. Now we know that this is going to be a low figure. Essentially, the Titanic disaster is known as one of the worst maritime disasters in history, and that is for good reason. That is simply because a lot of people died, but exactly how many people died is not something we know, and what is the probability of somebody surviving on the Titanic is also not somebody we know. But since it is widely considered a disaster, we can safely assume that the probability is less than 50%, or the survival rate is less than 50%. Whether it is actually less than 50% or not is something that we'll have to verify through the data set. Well, the other thing that we could find out by simply looking at these columns is that what is the survival rate by class. So by passenger class, what is the survival rate? If you've seen the movie, you might have seen those scenes where people from the second and third classes were locked up, or people from the first class or the higher classes were given preference when the ship was being evacuated and when the lifeboats were being filled. We have now an opportunity to figure out whether that was really true or whether it was just a figment of James Cameron's imagination. Let's see if survival rate differs by class and if actually the lower classes had a lower survival rate. Well, one obvious thing that we know about the Titanic is that women and children were allowed to evacuate the Titanic first. So essentially, survival rate by gender should be higher for women than for men. Let's see if that is true, and if actually it is true, which probably most likely it is, let's see what is the difference. The other thing that we have is a couple of variables related to families. So we could also ask something like, are people traveling with their families more likely to survive. So this is something that we can infer from these two columns over here. So that's it. Like those are broadly a few general questions that we can ask. Oh, and we also have the fare as a variable, which is how much the ticket had cost. So we can also ask something like, apart from this is basically a extension of the survival rate by class problem, were so we can ask something like, given that we have fare, were people who paid a higher fare more likely to survive? So let's find that out as well. So yeah, those are broadly the kind of questions that we can come up with when we think of unknown results as a pattern of insights. The next pattern of insight that we know of is called surprising comparison. So these are essentially questions like how does the survival rate compare between say gender, passenger class. Now maybe a couple of these questions we have already addressed here, but anyway, let's put them down here in the interest of completeness. How does the survival rate compare between age, for example? Are younger people more likely to survive, or are older people more likely to survive? And yeah, the other one other variable which we have not used so far is the embarkment. So whether you embarked on Cherbourg or Queenstown or Southampton, which of them makes you the most likely or the least likely to survive? So how does the survival rate compare between embarkment ports? Let's just call this embarkment for the sake of convenience. There we are. And then we can also ask some other question based on, this particular pattern of insight based on, say, the family. So we can say that how do number of family members compare across gender? So basically, do men have more family members or do women have more family members? Passenger class. And what this means is that which class of passengers has more and less family members traveling with them. Age, which what age, how does the number of family members vary as your age changes? So you would imagine that younger people, children would be traveling with their family members, and older people might not be traveling with their family members. Let's see if that is true. And again, as usual, the other variable that we have is embarkment. So let's see what happens. Now the next pattern of insight that we have is surprising extremes. Let's see what sort of thing we can come up with over here. So here we have to frame questions that are in the superlative. We ask questions about highest and lowest and things like that. So let's think about this. Yeah, one question we can ask is which passenger class had the highest or the lowest women passengers, or passengers, which passenger class had the highest or the lowest men or women. So gender ratio across classes. Let's see what that gives us. We can then ask who are the oldest and the youngest people in each class. So we are basically trying to combine extremes between the class variable as well as the age variable. And we can also say what was the highest or the lowest fare. And then we can group this again by age, by gender, by passenger class, and by embarkment. So there is a bunch of things that we have which we can use to do our analysis. And of course, like we can also say what is the highest or lowest fare by survival, because ultimately one of the things that people believe about the Titanic may be perpetrated by the movie is that people who paid higher fares were more likely to survive. Let's see if that is actually true. Then we also have abnormal distribution as another class or another pattern of insights. So let's see what sort of distribution we expect from this and what do we actually get. So we can ask something like, what is the distribution of passengers across well, age, uh, passenger class, fare. I'm not even sure if that really makes sense or not. Like basically, how do you even compare how many passengers paid what kind of fare? Not sure if that really makes sense, but let's leave it here for the sake of completion. This is basically more of an exercise in how we frame questions rather than how we actually do the analysis. The analysis is something that follows, and anyway, once we take a particular question and try to tackle it, how we exactly do the analysis and does the question itself make analytical sense becomes a different argument completely. And what is the distribution of passengers across yeah, embarkment? So essentially you would expect that few children, very few old people, but a lot of young and middle-aged people would be there by age. By passenger class, you would expect that very few people are in the first or second classes and a lot of people are there in the third class. As is true for most modes of travel. Fare, again, not too sure. Let's find out. And embarkment, again, we don't know what are the distributions of passengers that embarked in C, Q, or S. So let's take a look. So I guess this is a fairly large set of questions that we have, and let's tackle them one by one through our analysis and see what we can get to. So let's go back to the sheet with the data and try to start answering our questions. Well, the first question that we asked was, what is the survival rate? And that can be answered by looking at this column. We essentially have a binary indicator which tells us whether a particular passenger survived or not. So let's try and take a look at how we would solve this. Now, one way to calculate this is simply count the number of ones that are there in this whole column and divide them by the total number of rows. So essentially, we can simply say sum of A to A and then simply divide it by the count of A to A. Now we see that we get the value of 0.38, which means that the survival is 38%, quite less than 50% as we expected. So essentially what this means is that 38% of the passengers on the Titanic survived. Now if we look at the formula here very carefully, you will see that count A to A is the same as the length of that column, and when you have the sum of a column divided by the length of a column, that's nothing but the average. In general, whenever you have a binary variable like this one or a Boolean variable like this one, the average is often a proxy for the probability of the positive class. So instead of using this particular somewhat convoluted formula, we can simply replace it with average. So we can simply say average of A by A, and that gives us the same value, and that's a good proxy to have because average is a formula that we are familiar with and it avoids us writing a complicated formula. Now the next question that we had was, what is the survival rate by class? Now we have the survival rate in this particular column and we have already calculated it overall, and we have the class over here. So for what we need to do first in order to find the survival rate for each independent class is to filter this particular column by a particular class value. So basically for the third class, take all the rows which have 3 in this particular column and then compute the survival rate for those rows separately. Then do the same for the first class and then do the same for the second class. Now this is called a group by operation, and one easy way to do that in Excel is to use a pivot table. So let's write this down and let's go to the next cell, and in order to create a pivot table we go to the insert tab and we click on pivot table. Now it's going to ask us to select a table or range, and it has very helpfully already selected a range. Essentially, all of this boundary that you see with the dotted lines, that's basically the range that it has already selected for us. And what it's going to do is that it's going to use all of these columns to create the pivot table. Of course, which individual column to use for a particular metric, that is up to us. So let's click on OK, and here we see the details of the pivot table. Now we need to find out the survival rate by class. So we need a table which shows each class in a given row, and in the row next to it we need to see, or in the column next to it, we need to see the survival rates. So what we need to do is take the P class variable from here and drag it down to the rows section, and then we need to take the survive variable and drag it down to the values section. Now you see that it has already picked a particular aggregation for us, which is sum of survived. We don't need the sum here, we actually need the probability, which in this case is also the average. So in order to change the sum to the average, we can simply right click on this particular field and go to field settings, and here as we see we have multiple different aggregations which are available to us, and the default value is sum. We simply change it to average and then we click on OK. So there it is. Those are the survival rates or probabilities of particular classes. Now in order to make it a little more readable, let's sort this in a descending manner by the average of survived. So essentially we know that 62% passengers from the first class survived, 47% passengers from the second class survived, and 24% passengers from the third class survived. So this is fairly significant, and it's also fairly depressing in a way, because what this means is that of the people who were there in the first class, for every 3 people, roughly 2 of them survived, whereas in the second class every 1 out of 2 people survived, whereas in the third class 1 out of 4 people survived. So there is clearly a significant distinction between the survival rates of the different classes that were aboard the Titanic. Let's take a look at the next question. The next question is, what is the survival rate by gender? Now the answer to this is not something that should surprise everyone. We clearly know for a fact that women would have a higher survival rate, but that is also something that we know from our general knowledge or whatever. But let's see if the data actually holds up. And again, to do that, we have to create a new pivot table. We are going to use a ton of pivot tables in this particular exercise, by the way, simply because pivot tables are so convenient and they allow us to do a bunch of different operations very quickly. So again, we go to the insert tab and we click on pivot table. It's the same range as usual, and where we want to place the pivot table is this particular cell M10, and that is what it has basically already selected over here. And then we click on OK. Here we basically need in our rows the sex, because we want to figure out what is the survival rate for each individual gender. And then again we drag the survived column into the values section, and here also as usual it's basically giving us the sum. We don't want the sum, we want the average. So again we go to the field settings and then we change the sum to average and we click on OK, and there it is. So 74% of the females aboard the Titanic survived, whereas only 18% of the men aboard the Titanic survived. And that is obvious because we know that it's basically the females and the children who were allowed to evacuate the sinking ship before anybody else. So that answers our next question, which is what is the survival rate by gender. So let's add this also here. Let's give this a little more room so that we can read what we have done. Let's go to the next question now and see. Are people traveling with their families more likely to survive? Now, this is a somewhat compounded question. It's a somewhat complicated question. We don't know how to straight away answer with this because in our data set, we don't see a straight up column which tells us whether a particular passenger had a family on the Titanic or not. However, we do have two other columns from which this information can be derived. We know for each passenger how many siblings were on the Titanic or spouse, and we also know for each passenger how many parents or children were on the Titanic. So what we can simply do is take the sum of these two columns, and that output, the sum of siblings or spouses or parents and children, essentially gives us the number of family members that were there with a particular passenger on the Titanic. And if this number happens to be greater than 0, then we can conclude that somebody has a family on the Titanic. So let's try that. In order to compute this variable, we'll have to introduce a blank row and then fill that row with the sum of these two columns and then see if that column is greater than 0 or not. So let's insert a particular column that gives us this column. Let's simply call it n underscore family, which is the number of family members you have, and then we can simply do sum of this column plus this column and we press enter. So there it is. This particular person, which is Mr. Owen Harris Brond, had one family member on the Titanic. And as usual, we can simply drag this down all the way till the end to apply that particular formula to the entire set of rows. And we overshot it a little bit, but that's okay. We get a bunch of zeros. We can just reduce it a little bit and go down to exactly 892 columns, and there it is. So now we have a column which tells us what is the total number of family members a person had when they were on the Titanic. Now we can simply convert this into a Boolean variable. Basically, if you remember, the wording of our question was very specific. What we are asking is, are people traveling with their families more likely to survive? Which means that all we need to answer is whether somebody was traveling with their family or not, because whether they survived or not is already available to us here. So essentially, we just need to perform some sort of a logical operation on this column which tells us that if this number is greater than 0, then that person was traveling with their family, or if that number is 0, then that person was not traveling with their family. So let's introduce another column which we will simply call as family. And in order to populate this, again, we simply do an if operation. So an if is basically a formula which takes in a particular condition, and if that condition is true, it picks one value, and if it is not true, it simply picks another value. So let's say that our condition basically is h2 greater than 0. And if that is the case, we want to call it true, and if that is not the case, we want to call it false, and then we press enter. So let's copy this and paste it all the way to the end of the sheet. It went well beyond the range, so let's not do that because that will slow down the operation. And let's go back to the top and let's just drag this down until we reach 892 columns. There is a keyboard shortcut for this. Basically, you can just press a particular keyboard shortcut which will take you down to the end of that particular data, not to the end of the spreadsheet completely. But somehow on my computer I can't seem to make it work. So there it is. Essentially, this particular person had 5 family members, so therefore they were traveling with a family. This person had 3 family members, so they were traveling with the families, and others were not. So wherever there's a 0, we conclude that that person does not have a family, and if there is a 1, then that person has a family. So let's go back all the way up. Now, the question we had was, is a person with a family more likely to survive or not? So essentially what we need to do is find the survival rate depending on whether a particular person has a family or not. So again, we use a pivot table, go back to the insert tab, click on pivot table, and the same range is selected. The new output range or the cell is also selected. We click on OK. That gives us the pivot table, and then we say that what I want in my rows is basically whether a person had a family or not. Well, it seems like those particular columns are not showing up. So let's see what went wrong with our selection. Let's close this and delete this particular pivot table. Well, we can just, instead of pressing the delete key, we can just press the undo key to make this work. Now let's see why it did not create the pivot table correctly for us. Remember that we need the I column over here. When we click on the pivot table, you see that it's actually picking up the hash family column itself. So let's see why it wouldn't pick up the pivot table also. Well, let's see if we can directly select the columns like that and then make a pivot table. So essentially, instead of making a selection on its own, we are creating a pivot table by ourselves. So we make the selection and we click on the pivot table, and we say that we want to place the pivot table in the existing sheet over here, basically. So essentially, let's click on OK. Now we have the ith column, and this time it says that a pivot table cannot overlap another pivot table record. Well, we did not remove the original one, so let's do that. And then again, select all the rows from all the columns from A to I and click on pivot, insert pivot table. Again, we want the result to come up in the existing sheet, which is over here. Let's click on OK. And there it is. We have the hash family variable available to us. So let's drag that down to the rows, and let's, as usual, pick the survived column and drag it down to the values. The sum, which is the default aggregation, let's change that to average. So instead of getting the total number of people who survived, we'll get essentially the probability of them surviving. And there it is. Essentially, the idea is that if you have a family, you have a 50% chance of survival. If you don't have a family, then you have a 30.3% chance of survival. Let's see how we can make this a little pretty. We want to make it descending, and we don't want to see any blank values over here. So there it is. And let's again format this as percentages, just in the interest of better presentation. So there it is. Nearly 51% people who have a family survived, and only 30% of the people who did not have a family survived. Now, one of the reasons why this could happen is that you can imagine a typical family consisting of a father, a mother, and two or more children, or even one child. And you see that since women and children were evacuated first, it's possible that even within a family, the rate of survival is something around at least 50%, because there would be a man and a woman. And if there are children, then the rate of survival would be more, for if you consider a given family as the unit which we're considering for this particular probabilistic analysis. So that's why it makes sense that people who were traveling with families had a higher rate of survival. The only way that you would not survive if you were in a family on the Titanic is if you were a man. So that's why this is not too surprising. Let's see what our next question is. So, were people who paid a higher fare more likely to survive? Now, let's think about how we could calculate this. What we can do is simply have the fare over here, and let's format this as currency. So here we can go to the formatting tab, and we say that we want to format this particular thing as a currency. Now, clearly it has picked the Indian rupee as the currency symbol, but we can go a little ahead and click on more number formats, and instead of the rupee symbol, we can use the Great Britain pound. The reason I've chosen Great Britain pound is because the Titanic started its voyage in England and it was going to the US. So the fares are likely to be in British pounds, not in American dollars or rupees, obviously. So let's leave it at that. And there it is. The idea is that we now want to figure out, does paying a higher fare mean that you are more likely to survive? Let's think a bit about how we would do that. Here again, also it's a case of bivariate analysis where we have one categorical variable which is simply true or false, and we have one numerical variable which is the fare. So does increasing fare mean a better chance of survival? Let's think about it. Well, since one of our variables is actually a categorical variable, here also we have no choice but to do a group by. Essentially, we are going to figure out if somebody survived or not and then check the average fare they paid. So essentially we can say something like average fare by survival, and again let's insert another pivot table. So here's basically seem to have messed up the selection, but let's cancel it anyway and let's restart again. I clicked in the wrong place and that messed up the selection. So here's a selection and we want to place the result in the cell O18, which is basically the cell, and we click on OK. And here what we want to do is we want to have the survived factor as our rows, and we have the fare factor in our columns. And here we have sum of fares. Again, let's change that to average fares. One of the reasons we use average so often is because it gives us the best of the worst kind of an estimate. So there it is. The people who did not survive had an average fare of 22.1 GBP, whereas those who survived had an average fare of 48.39 GBP. Clearly means that the people who survived were basically paying more than twice the amount on average of people who did not survive. This is also a very stark contrast and somewhat surprising result, because you would not expect to find any correlation between what fare people are paying versus whether they survived or not. But anyway, that's what the data tells us. So let's continue. So the next question is, amongst surprising comparisons, how does the survival rate compare between gender? I think this is something we have already answered. So if we go back to see the survival rate by gender, we have already answered how survival rate changes from men to women. So that question is answered. We have done the same for passenger class, but we have not done that for age. Essentially, we need to see how survival rate changes as your age group changes. Now, in order to do that, we are going to have slightly complicated type of a pivot table. So let's take a look. So let's write down the metric we are trying to measure here, which is rate of survival by age. Now here too we need a pivot table. So let's go ahead and insert a pivot table, same range, and there we are. Now here amongst the rows we basically want ages. So let's take the age column and drag it down to rows. So there we have all the different ages that are present in the data set. We see that it's a fairly large list. We might want to group it down, but let's see what happens. And again, as usual in the values, let's drag the survived column. Here again, it's the sum of survived. Instead of that, let's do the average of survived. So there it is. Now you see that we have ages which are 0.42, 0.67, 1, 2, 3, 4, 9. Basically all integer ages are there. There are also floating point ages in between. So instead of dealing with ages as the raw numerical number that they are, let's group them together into bins. And one way to do that is to simply click on one particular age value in the table and click on the group selection button over here, which is available under the pivot table analyze tab of Excel. And so when we click on group selection, it gives us a menu. So it's basically saying that starting at 0.42, which is the lowest value, and ending at 80, which is the highest value, we want to group the whole range in groups of 10. Let's start a little lower than 0.42 because we want the range to slightly exceed the actual range. And instead of ending at 80, let's end at 90 and group it into 10. And then when we click OK, we see that the data becomes a lot more compact, and instead of having a survival rate at each unique value of age that is present in the data set, we get aggregated survival rate for different ranges of these values. Now those are our values. Let's sort this by decreasing order, and we want to sort by the average of survival. So there it is. Basically anybody who is between 80 to 90 years of age had a 100% chance of survival. But at the same time, that you see that somebody is between 70 to 80% of age has a 0% chance of survival. This probably is a fluke value. What that means is that there's probably one or two passengers who are in that age range, and it just so happened that both of them survived, or whatever number there were in that range happened to survive, and that's why it's getting a high rating. But the same cannot be said of other values. Clearly, for lower values, which is 0 to 10, or we see that the survival rate is pretty high, which is 60%. And that makes sense. Children were allowed to evacuate first, but at the same time, if you look at the range of 10 to 20 years, the survival rate falls a lot more below. So there it is. These are the different survival rates as grouped by age. Now the next question that we have is, how does the survival rate compare between embarkments? So let's try that as well. Here again, let's click on the cell where we want to add our pivot table. Let's go to insert, and again insert a pivot table, same range, and when we click on OK, we get the pivot table menu. Here we are talking about embarkments, so let's drag back to a rows field and survive to the columns field and change this to average, and there it is. So again, we can clean this up a little bit, say that we don't want to see the blanks, we want to sort by the age of survived in a descending order, and there it is. So basically the people who embarked on C, which is, let's take a brief look at what that is: Cherbourg, Queenstown and Southampton. So basically the people who embarked on Cherbourg had the highest chance of survival, whereas those who embarked on Southampton had the lowest chance of survival. Let's select these and format these as percentages in the sake of better presentation. So there we are. So you see that most of these questions we have been able to answer through a variety of pivot tables, and that is why if there is one thing that you learn about Excel, it's probably going to be pivot tables. So that's pretty useful. So let's proceed to our next set of questions. The next question is, how do family members compare across gender? So essentially what we need to do is find out how many family members on average each particular gender had. So we can say something like this: number of family members by, let's say, gender, and let's insert our pivot table over here. So let's go to the insert tab, click on pivot table, and this time we want to group the number of family members by gender. So what we need to do is put the sex in the basically the sex column. From here we want to drag it into rows. That gives us male and female, and we still don't have the number of family members columns, which is in family. Again, as happened in the previous case, the selection has failed to take these things into consideration. Let us try and recreate the table again. So let's undo this and see if we can create this particular table, and we also had basically the gender column. So then again we click on insert and we click on pivot table. So there it is. It has not picked up the correct one, but we can add it over here. We can say that we want to pick up the range from D and we want to pick up the H. So there it is. We only want it to pick up these two values, and that's good enough for us. And we want to add the result in an existing worksheet, which is this one, over all the way over here. So let's click on OK. It says that the data source reference is not valid. Let's see what can go wrong over there. Let's cancel this and actually force select all the columns from A to H, and that should give us our correct selection for the pivot table. So there it is, and we want to add it to the existing worksheet over here, and then we click on OK. And if you look at it, yeah, this time the number of family members has come up. So let's say that we take the sex in the rows column, that gives us male and female, and we also take the n family members in the values column. Again, let's convert the sum to an average, and there it is. So here it is, and let's clean this up and say that we don't want to see any blanks and reset the table. So females had almost twice the average family members than men, and this is also understandable, probably because women were not allowed to travel alone and they would be accompanied by their family, whereas men could travel alone. And there it is. So basically that's basically how number of family members varies by gender. So the next question is, how do the number of family members compare across passenger class? We could simply create another pivot table, but for convenience, we can just modify this existing pivot table. So let's see how to do that. We can just delete this particular row from here. We can say remove field, and since we want to have a comparison across the number of family members, which we already have the average of here, and amongst the rows we want the passenger class, so we can just drag this over here, and that's how it changes. So let's also try and modify this a bit. We can say that we want to see this in the descending order by the average number of family members and not want to see any blanks. So there it is. So that makes sense. Essentially, between the first and the second class, the average number of family members is 0.7, and in the third class it's 1. So essentially most of the people in the third class on an average were traveling with one other family member, whereas people in the first and the second classes had smaller families. Now the next few questions, which is how do number of family members compare across age or embarkment, those are simply modifications of the same pivot table that we have already added. So you can do them as exercises, but let's move on to the next pattern of insight, which is surprising extremes. So let's take a look at the first question that we asked. Which passenger class had the highest or the lowest passengers? So let's take a look at this. This also requires a kind of a pivot table, but a slightly different aggregation. So let's go and insert the pivot table over here. Say that's the correct pivot table. Here we basically want to insert the passenger class amongst the rows. Now in the values, since we simply want the count of the passenger class, we can take any other column. So let's just take something like survived, but this time we, instead of the sum, we want count. So when we go to field settings, and we can simply replace them by count and click OK. So that's basically the idea. In the first class we had 216 passengers, in the second class we had 184 passengers, and in the third class we had more than twice of any of the other two classes, 491 passengers. So that makes sense, like third class was the largest class of passengers. Let's move over to the next question, which is, which passenger class had the highest or the lowest, men or women? So let's take a look. We can again insert a pivot table. And here also we need to do a count. So along the lows we want the passenger class, and along the values we want the sex fields. But here in the case of this particular sum, we basically want to change it so that we can just do a differentiation between men and women. So it seems like this is not something we can have over here. We can also drag sex into the columns, so that will basically give us the male and female part separately. So there it is. Essentially, in the first class there were 94 females and 122 males. In the second class there were 76 females and 108 males, and in the third class there were 144 women and 347 males. We can also take this a step further and actually calculate the gender ratio. So essentially that is simply the number of women divided by the number of men in that particular class. And let's take a look at what that tells us. So we have this value. You'll see that a large formula has appeared here, but that is because this is not a literal value, this is a computed value. The pivot table has actually computed that value for us, and then we divide it by this particular value and we press enter, and that's basically the gender ratio for the first class. Again, let's do the same here. We say that we want to divide this value slash this value, and there it is. And then again, for the last class, we say we want to divide this value by this value. And then again, for the sake of presentation, let's format these as percentages. And here is where we see our first surprising output. Essentially, the gender ratio of the third class is the lowest of the three classes. We have steadily decreasing gender ratios between the first and the second class, but they are still fairly high, 77% and 70%. But a gender ratio of only 41% is too low. Why this is important is because the gender ratio in the third class of passengers was very low. It is also possible that it is because of this that their overall survival rate could have gone down. Now, we can divide the passengers into using any of these columns. Essentially, we can divide them by survival, you can divide them by passenger class, we can divide them by age also, sex also, but that is trivial. We can divide them by age and where they particularly embarked and so on. Whichever way we try to divide our passengers, if in that particular cohort or in that particular classification of passengers there are more females, then it is likely that the survival rate of that particular group of passengers is going to be high. So essentially, if we were to divide them by class and we see that a particular class has more females, then the overall survival rate of that class gets pushed up. At the same time, if we were to divide age groups into a bunch of if you were to divide passengers by age groups, and if a particular age group has more women in it, then simply because there are more women in it and because women were basically allowed to evacuate the Titanic before the men, that fact alone pushes the survival rate of that group. So basically, so far we have seen that the survival rate by class of the third class is very low. And one of the reasons why that could be happening simply is because their gender ratio is very low. If they had enough, if they had a high enough representation of women, well, representation is a wrong word. If they had a high enough gender ratio, then it's possible that their overall survival rate could also have increased. So there we are, and let us continue with the questions. Now you see that many of the following questions can also be solved again just by extending the same sort of pivot table and cross tabulation that we have been doing so far. So let's jump directly to the next section of insights, which is abnormal distributions. So let's take a look at what is the distribution of passengers across age. One quick way to do that simply is to draw a histogram, and as we know, we can simply select a column and go to the insert tab where we are going to see a bunch of charts. Now let's take a look at recommended charts. Sometimes what you find is directly available in the recommended charts, and there it is. So we want to draw a histogram. Now what this tells us simply is that most people fell in this particular bucket, which is basically the age group of 17.5 to 23 years. So most people were actually between the age of 17 and a half and 23 years. We had quite a few people who are below 6 years of age, and we had very few people above 63 years of age. We see that we have less than 10 people who are basically above 63 years of age. Now we see that since we have so few old people, it's one of the reasons why basically the survival rate of senior citizens over here is so high. It's basically when we try to calculate the survival rate of the passengers by age, we saw that in the age group of 80 to 90, the survival rate is 1. That simply could be because there is exactly one fellow over here, one particular passenger who happened to survive, and that's what's pushing that survival rate to a very high value. And that clearly, the age decreases as the number of people who are older decreases, and there are a bunch of people who are young. There are a lot of people who are young adults. There are a few people who are middle aged. So when we say that we are looking at the distribution of a particular column, essentially what we're doing is talking about what its histogram looked like. And we don't see anything surprising over here. So this is not what we would call an abnormal distribution. Let's take a look at the next question, which is essentially what is the distribution of passengers across passenger class. Now, if you think about this, a simple way to do this would be simply to take the counts of all the passengers in all different classes and sum them up. But we have actually already done this. So essentially we have the three classes over here and we have the grand total of the passengers over here. So we can just select these three rows and create a new chart out of this, instead of actually creating a chart through the usual way, which is recommended charts doesn't show anything. All of these charts will not work. So for example, if I try to click a 2D line, it's basically going to give me this, but this doesn't tell me anything. One easy way to essentially click or basically view a particular chart which is coming from the result of a pivot table is to straight away look at pivot chart, which we see over here. So let's look at the pivot chart, and there it is. Essentially, this is the distribution of passengers across the three classes. We see that this also reflects what we know about the gender ratio. It's high in the first two classes and it's very low in the last class, and there are far too many men in the third class. So not entirely surprising that this particular class received many fatalities. So yes, this overall may not be a abnormal distribution, but what is abnormal over here is essentially the gender ratio. It should not have been so low. But then there might be certain socio-economic factors which have led to this. Obviously, the people who were traveling in the third class were poor people. And remember that the Titanic sank in the year 1912. And those were the times when Europe was in the grip of the First World War, or at least the onset of the First World War. The economy wasn't great, and a lot of people were leaving their European homes to travel to the United States. And one of the reasons why United States was a major destination at that time was because it had largely been untouched by the First World War. So that is why it was perhaps a reasonable choice for a lot of men to go and seek employment in the United States. And obviously, they probably did not have the resources to carry their families with them. If they had, then maybe this gender ratio would have gone up. But that didn't happen, and unfortunately, the Titanic sank, and so did all at least most of these people who were traveling in the third class. Now, all of that, by the way, is just a hypothesis which I have put together in the spur of the moment using some of my own general knowledge, obviously. If you would like to actually validate this with data, you're most welcome to do so and maybe treat that as a homework assignment. Let's take a look at the next question, which is essentially what is the distribution of passengers across the fare. So essentially what we want to do is simply take the histogram of the fare column. Let's move this chart out of the way. Let's select fare and simply go to the insert part and click on recommended charts. We see that we have a bunch of charts, and let's particularly pick the histogram, and there it is. We see that a lot of passengers paid like really low values, and basically about 500 passengers paid less than 18 pounds or whatever the currency is. Many of them paid between 18 to 36 pounds, many of them between 36 to 54, and it goes on decreasing. And that makes sense because the cheapest ticket went to the largest class of passengers. But this is definitely somewhat abnormal because you would expect the curve to fall, obviously, because a lot more people will be paying say cheaper tickets, paying for cheaper tickets, and a lot fewer people would be paying for more expensive tickets. But you wouldn't expect the curve to fall so quickly. You would probably expect it to fall a little more smoothly. Essentially, what this means is that there is this one slot of tickets which has 500 people, and the second slot has less than half that amount, which doesn't make really too much sense. At the same time, we don't even know what sort of division there is between the fares by class. What is exactly the threshold here above which we have the first class rates, below which we have the second class rates, and so on. Maybe that can be inferred from the cabin information over here. So if somebody has too many cabins, they, like for example, this particular person has 3 cabins allotted to them, and we might want to figure out whether that leads to a higher fare. Clearly does. You see that 263 pounds is a fairly high value over here. So in summary, this chart that we see here, well, it's definitely an abnormal distribution, at least until we can dig deeper and find out what is exactly the logic behind a fare curve that falls so sharply. So this is broadly how you can apply patterns of insights and come up with different questions and use those questions to drive our analysis. We saw that we went through all the patterns of insights, we drafted a bunch of questions, we did not solve all of them. In fact, you're welcome to solve the remaining questions on your own and share them with us during one of our interactive sessions. That would make for a really good exercise. And You see that just by following this process rigorously, we have at least 2 or 3 very solid things to say about the data set. And that is kind of the point of patterns of insight. If you rigorously follow those patterns, if you carefully frame your questions and actually chase the patterns down carefully, you will have at least a few very insightful things to say to your client, to your audience. And that is how they are intended to be used. So I hope you have fun with this. All the best, and I'll see you next time.